All right, so let's look at the trigonal bipyramidal electron pair geometry and how to build your structures for this electron pair geometry. In this one, we'll look at 4 molecular geometries, which is, of course, models 7 to 10 in your guide. So let's get 4 little ones for that. So I just need to check that all of them are that. So of course, what you're looking for is something. So if you look at that, if I place it down there, I'm going to try and take my hands out of the way. It's something where it has equatorially has a trigonal planar structure, so meaning, or trigonal planar bonds, so meaning 3 bonds in the flat plane that are 120 degrees separated, and 2 bonds that are then in the axial plane, so meaning that plane, that are separated by 180 degrees. Okay, that's what you're looking for. All right, then once you have them, we can start with model number 7. Model number 7 is, of course, always the parent structure. So it's always the first one is where the electron pair geometry is equal to the molecular geometry. And you just build that one, just put everything on everything, and we just plug in. Okay, and this one, so it's trigonal bipyramidal, and the electron pair geometry trigonal bipyramidal is equal to the molecular geometry trigonal bipyramidal. And here you can see, right, there we have that, trigonal bipyramidal, so meaning trigonal in the equatorial plane, we have trigonal bipyramidal, so meaning on both sides it's like a pyramid. So there's a pyramid on top and a pyramid at the bottom. So if you look at it now, you'll see there it is, right? So there's 90 degrees here on top, 120 degrees in between these bonds in the middle, and then 90 degrees there at the bottom again, and the 180 degrees between the 2 atoms, terminal X atoms here above and below. Okay, so you can go and look at that one. All right, so let's go again now, seeing how can we get to model 8. The question is, how do we get a seesaw? So it says, how can we use this to construct what we call a seesaw? So if we need to remove one of these terminal atoms, where do we remove terminal atoms to construct what they call a seesaw structure? So meaning model 8. And the answer is you remove one of these equatorial bonds. So, oops, that one was a bit tough. So meaning one of these that are in the one where there is 3. So the trigonal part, the ones that are removed by 120 degrees. All right, remove one of them and you replace it with a lone pair. Okay, because then if you put it down, you'll notice it goes like a seesaw. Okay, maybe that's the first time you've seen that now. You see it goes like a seesaw. If you put it down there, those 2 atoms that remain in the equatorial plane act as your pivots, and then you seesaw the thing. Okay, I'm going to stop playing around now. That's model 8. Okay, so you can build that then. Model 9 is called a T-shape. So we keep on removing stuff in the equatorial plane, and we add another lone pair in the equatorial plane. There we go. And can you notice how you got a T for telephone? All right, look at the T there. Okay, you notice how it makes a T-shaped. All right, with your 2 lone pairs there. Now, I apologize that I just bumped the table. Now everything's shaking, but anyway, you got the point. All right, there we go. So there's your T-shaped. You notice where I've removed those 2 bonds. It's in this plane. All right. The last question is, how do you get the linear structure? So how can you use this structure to represent a linear structure? Which covalent bonds should be replaced with a lone pair to get a linear structure. So meaning now that we are here, so which of these bonds do I still need to remove to get a linear structure, right? So, I mean, simple question, maybe, if you're looking at it like this, but I mean, if you remove this bond, for example, then you're left with that, right? You'll get something that's two bonds that are separated by 90 degrees. So it means that you have to remove something that's, well, that's not going to give you something that's separated by 90 degrees. So you, of course, go ahead and remove this last bond, and it then gives you a linear structure. Okay, and there you can see your linear structure. Kind of looks like a fan. All right, and now we can build all four of these models 7 to 10. Okay, so now you're probably going to run out of bonds, or not bonds, you're going to run out of terminal atoms, because I'm running out of terminal atoms. And that's okay, because you can just leave them open if you do. So there's our parent structure. Okay, put it down there. Then we add some more bonds here. So this one, okay, so let's add one lone pair. Loop, there's a lone pair. I'm going to add as many of these. The colors don't matter, right? Because at the moment we're not representing anything really. We're just interested in how they look. So that's our seesaw. Okay, so that one, seesaw, and then the final one is the T-shaped. So it's going to be one there, there. Oh, might still work. Okay, so that's going to be fine. And then we add two pedals over there. Okay. T-shaped, seesaw. So let's pack them in order. There we go. Then we have the seesaw. Then we have the T-shaped. And then we have the linear structure. Okay. All right. So here you go. There are models 7 to 10, all from the trigonal bipyramidal electron pair geometry, with your molecular geometries of trigonal bipyramidal, seesaw, T-shaped, and linear. All right. We still have some models to go, so I'll see you in the next video.